Solve the logarithmic equation. Log 5 to base x minus 6 log x to base 5 is equals to 1. So from here, you cannot use the laws of logarithm because we have different bases, isn't it? So we have to see a way of eliminating the log, isn't it? So here, if you have log 5 to base x, that implies if you have log b to base a to b to be y, then it means log a to base b is 1 over y, reciprocal, isn't it? So this is log 5 to base x, then this other one is log x to base 5, meaning one is reciprocal of the other. So if one is reciprocal of the other, if we let log 5 to base x to be y, if you let log 5 to base x to be y, then what does that imply? The reciprocal of log 5 to base x is log x to base 5, isn't it? The reciprocal will now be 1 over y, isn't it? Yes. You have to eliminate the log because we have different bases and one base is unknown. If all the bases were known, then there are another criteria of dealing with that, isn't it? So from that, what do you have? Do the substitution. So where there is log 5 to base x, you put y, isn't it? So then we have y minus, then we have 6, where there is log x to base 5, you put 1 over y. So it means it is 6 over, because 6 times 1 over y is 6 over y, isn't it? To be equals to 1, isn't it? So we have to get this y in the derivative of y in the denominator, isn't it? Meaning we multiply both sides of the equation by to get rid of this denominator, isn't it? So y times y is y squared, then minus y goes with y, you remain with 6 is equals to 1 times y is, then you rearrange quadratic, isn't it? Bring positive y, this side becomes negative y. So we have y squared minus y minus 6 is equals to, you use quadratic formula of factorization, isn't it? Factorization, which numbers gives you a product of negative 6 and a sum of negative 1? That is negative 3 and 2, isn't it? Negative 3 and 2. But it's easier to use quadratic formula, isn't it? So there you have y squared minus 3y plus 2y minus 6 is equals to 0. So from there, if you solve, what do you have? Here we have y into y minus 3, then we have here plus 2 into y minus 3 to be equals to 0, isn't it? So this is y plus 2 into y minus 3 is equals to 0, isn't it? Are we together? So what does that imply? It implies either y plus 2 is equals to 0 or y minus 3 is equals to 0, isn't it? So what is y? Y in the first solution there is negative 2, or y is positive 3, isn't it? So once you found the two values of y, then you now get x, isn't it? You get x. Can you now get x? What is x? Log 5 to base x is y, isn't it? So you come and put y is equals to log 5 to base. Are we together? Remember, y is equals to log 5 to base x. That is what you let, isn't it? So that is what does it mean? Where there is y, the first value of y is negative 2. So it means negative 2 is equals to log 5 to base, isn't it? Yes. So using laws of logarithm, x is the base. So x is the base, you put your x is the base, then corresponding number is 5. Is 5, then the power is negative 2. Are you seeing? Are we together? Because it's supposed to be the log of corresponding number. So log of corresponding number, meaning corresponding number is 5. And the base is x. So it means this 2 is the power. Log is always for the corresponding number, isn't it? Are we together? By definition of logarithm. So for you to get x, what do? So you multiply both sides by negative 1 over 2. So that negative 1 over 2 times negative 2, you remain with x, isn't it? So x is equals to 5 raised to negative 1 over 2, isn't it? Yes. If you like, you can do it further to get a decimal, or you can leave it just like that. Negative 5 raised to negative 1 over 2 is just 1 over 5 raised to power half, isn't it? Or 1 over square root of 5, isn't it? 1 over square root of 5 is just the same as, in size, is the same as square root of 5 over 5. Isn't it? Yes. Good. The next solution is when y is 3, isn't it? When y is 3, so we know that y is equals to log 5 to base x. Y is log 5 to base x, isn't it? So y is equals to 3. Where that is y you put 3, isn't it? So our base is x. So you put your base is equals to corresponding number. It is always the log of the corresponding number, isn't it? So corresponding number is 5. And now 3 is the power index, isn't it? So 3 is log of 5 to base x. So you can see 3 is log of 5 to base x by definition, isn't it? Are we together? Yeah. So what is x from here? X is 5 raised to power 1 over, meaning you multiply both sides of this by a third to remain with x. Because a third times 3, you remain with x raised to power 1, which is x, isn't it? Good. So you get x is 5 raised to power a third, or cube root of 5, isn't it? Good. So that is how to handle problems